All right, we're going to use StatCrunch to go ahead and complete this particular problem. The problem states a travel association claims that the mean daily meal cost for two adults traveling together on vacation is $110. A random sample of 20 such groups of adults has a mean daily meal cost of $115 and a standard deviation of $5. Is there enough evidence to reject the claim at alpha equals 0.05? Complete parts A through D below. All right, first thing that you need to understand for this one is what kind of test are we looking at? Are we looking at a one-tailed test? And if it is a one-tailed test, is it right-tailed or left-tailed? Or are we looking at a two-tailed test? In this particular case, if you come up here and you look right here where it says traveling together on vacation is $110, that means equals 110. So we're going to be looking at a null hypothesis of the mean being equal to 110. And that means that the alternative would be that the mean is not equal to 110. That's going to be a two-tailed test. And you'll see that this particular hypothesis is stated as such. So how do we go ahead and figure out how this works? Well, we're going to left-click StatCrunch here, and that's going to open up. And it's going to load, and then we don't have data to list, so we're going to left click stat. We're going to scroll down to T statistics, because if you remember in the problem it stated a random sample of 20, which is less than 30. So then we're going to go to one sample, and we're going to go with summary. Left click with summary, and now we're going to type in the sample mean. Now remember that the sample mean for this was $115. The sample standard deviation was $5, and the sample size is 20. Now our hypothesis test, remember that we were going to say that the mean was equal to 110, so the null hypothesis reads as mu equals 110. The alternative hypothesis, H sub A, mu is not equal to 110. Simply left-click compute, and we end up with this pop-up screen. That tells me exactly what the standard error is, the degrees of freedom, the t-statistic, and the p-value. I can log in the t-statistic at 4.47 because my stat lab said to round it to 2 decimal places. So let's go ahead and do that. That was already typed in, and we're in good shape. Now what's the p-value? Well, the p-value for this is going to be 0.0003. And that says round to 3 decimal places as needed. Well, 3 decimal places, that's going to be 0.000. So let's check that, and it tells me that I did a good job on that. Now decide whether to reject or fail to reject the null hypothesis. All right, for this, we're going to look at our choices, decide whether to reject or fail to reject the null hypothesis. I don't even need to read these four, because simply stating when I look at the p-value of 0.000, and then I compare that up here to my alpha equals 0.05, the p-value is less than the significance level, so I will reject the null hypothesis because the p-value is less than the significance level. So we check that, and we're done, and we left-click continue, and it says interpret the decision in the context of the original claim. All right, let's interpret the decision in the context of the original claim. Now, in this particular case, we know that our hypothesis was that the mean was $110. In other words, that is the claim. The mean daily meal value is for two adults traveling together is $110. Since we reject the null hypothesis, since the p-value is less than the significance level, then there is sufficient evidence at the 5% significance level to reject the travel association's claim that two adults traveling together on vacation will spend $110 for meals. So we'll check the answer. Good job, and we're done with this.